Hello guys, welcome back to my YouTube channel. Today I am going to solve day 13 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 861, score after flipping matrix. Okay, so in this problem you are given an m into n binary matrix grid. Okay, so when my binary matrix grid is given to us, right? So m is nothing but the number of rows and n is nothing but the number of columns. Okay, so how we are going to get the number of rows? So there is one simple formula, right? Int rows is equal to grid dot length. So okay, so it is going to give me the number of rows, and int columns is equal to grid 0. So I am just selecting first row and I am just calculating the length of first row. So it is going to give me the length of the columns. Okay, so here I have created two variables, rows and cols, for calculating the length of rows and length of columns. Okay, so this is clear. Then after that, a move consists of choosing any row or column and toggling each value in that row or column, changing all the zeros to ones and all ones to zero. Okay, so see here, this is example 1 here, right? So this is the initial matrix, right? This is the initial matrix given to us. So in this initial matrix, first we are just changing the all the numbers in the first row. Okay, in the first row. Okay, so see here all the numbers. Okay, so let's do one thing. Let's name it as row 0, name it as a row 1, row 2, and this is my column 0, column 1, column 2, and column 3. Okay, so initially see, we are just changing all the numbers from 1 to 0, from 0 to 1 in my row 0, right? So see, right? And after that we are changing all the numbers in my column 2, and then in the end we are changing all the numbers in my column 3, right? So see, every time I am just choosing any row or column and then toggling each value in that row or column. Okay, so changing all the zeros to ones and all the ones to zero, right? So after that, every row of the matrix is interpreted as a binary number. Okay, so this is nothing but a binary number, and the score of the matrix is the sum of these numbers. Okay, so we have to just return the highest possible score. Okay, so see here, first just tell me one thing. Okay, how I am going to write 1 in binary form? So I am going to write 1 like this now, 0 0 0 1. How I'm going to write 2 in the binary form? I'm going to write 2 like this, 0 0 1 0. How I'm going to write 3 in binary form? I am going to write 3 like this, right? 0 0 1 1. How I am going to write 4 in binary form? I am going to write 4 like this, 0 1 0 0. Okay, same way how I'm going to write 8. Okay, so I'm going to write 8 like this, 1 0 0 0, right? So what is the value of this bit? 2 raised to power 0. What is the value of this bit? 2 raised to power 1. What is the value of this bit? 2 raised to power 2. And what is the value of this bit? 2 raised to power 3. Okay, so simply I can say that this bit value is 1, this bit value is 2, this bit value is 4, and this bit value is 8. Okay, so I hope that this statement is clear, right? This we already know. Okay, okay, so now just tell me, uh, I need to return the maximum sum, right? I need to return the maximum sum, right? So every time if I am forming this set, I am forming a binary number with this set of bits. Okay, so every time if this bit is set to 1, right, then every time I am going to get one maximum number only, right? Every time I am going to get one maximum number. Okay, so see here, if I see here, just take this example. Okay, take this example. Okay, so in this example this bit was set. Okay, this bit was set, but this bit was not set in 3 2 and 1 previous numbers, right? So what is the maximum number? 4 is the maximum number. Okay, so here for for this 8 number. Okay, for this 8 we are setting this bit. Okay, we are setting this bit and all the other bits are 0, but we are setting this bit. Okay, so this 8 is maximum, right? Then all the previous numbers, right? 7 6 5 4 3 2 1, right? So what we can say that here, this is my most significant bit, right? And this is my least significant bit. Okay, so in this example or any example, okay, in this problem we need to make sure that our first our first column, or I can say, let's say column 0 is always going to consist of most significant bits, always consists of 1. Okay, so my column 1, column 0 should always have ones in all the places, right? Because if there is 1 in the most significant bit position, then in that case only I can form the maximum number. Okay, so I hope that this line is clear. So initially I am going to check row by row. Okay, so initially I am going to check for this row. Okay, so in this row, first cell, okay, this I am checking row by row right now. So here this value is 0, right? So I need to change it. So this is my matrix. Okay, so I am saying that this bit is 0 initially. Okay, but to make a maximum number I need to change this number to 1. Okay, so what I'm going to do, I'm going to flip all the bits in my row 1. Initially I'm going to flip all the bits in my row 1. Okay, so after flipping all the bits in my row 1, so my result is going to look like this: 1, this 0 will change to 1, and this 1 will change to 0, and this 1 will also change to 0. Okay, and all the other values are same, right? 1 0 1 0. So see, you can just take a look at this. Okay, all the values are same, so we are just changing the first row values, right? Then after that I am going to check for this row 1. Okay, in this row 1, initially the most significant bit is already set to 1, so I don't need to do anything. Then I am going to check for the row 2. So in here initially most significant bit is set to 1, so I don't need to change anything. Okay, this is done. Then after that I have to check column wise. We need to check for the columns, right? So here, since in column 0 all the bits are already set to 1, okay, all the columns are already set to 1. Now we are going to check for the column 1. Okay, so in column 1, in column 1, just tell me how many number of bits which are 1. Okay, so number of ones are 2 and number of zeros is 1. Okay, so in this case we don't need to do anything, we don't need to change anything. Okay, because we don't need zeros. Okay, we don't need max zeros in my column 1 position, we need max ones only. Okay, that is why I'm not going to change my column 1. Okay, because every time we can either change our row or column. Okay, so if I change this entire column 1, then definitely I am getting result as 0 1 0. Then there is just one bit set. Okay, there is only one bit whose value is 1 and all other bits set to 0. Okay, so I don't need to change it, so I'm not going to make any changes in column 1. Then in column 2 I'm going to check how many zeros and number of ones are there. Okay, so number of zeros are 2, which is greater than the number of ones, right? So I am going to flip all the bits. After flipping all the bits, the result is going to look like this: 1 0 1. Okay, so see, this is clear. Then after that I am going to check for the column 3. Okay, this is my column 1 and this is my column 2. This is column 1, right? So in column 3, number of zeros are 3 and there is no 1. Okay, so definitely I need to change it to 1. Okay, since number of zeros are greater than number of ones, so I need to change it. So after changing, all the bits are changed to 1. Okay, so this is done, right? This is done. Okay, because we need the max number of ones. Okay, so from here two things is clear, 2 points are clear, right? First we are going to check row by row and we have to make our most significant bits as 1. Okay, this is the rule number 1. Okay, after this rule we need to check column wise. Okay, and in each column we need to make sure that ones are more than number of zeros. Okay, so these are the 2 points that we need to take care. Okay, so once this is done, then after that, this is my final result, right? So in this final result, what is the value of this 1 1 1 1? So it is looking like this, na? 1 1 1 1. Okay, this is nothing but 2 power 0, 2 power 1, 2 power 2 and 2 power 3. Okay, so what is the total value in decimal form? So 1 plus 2 3, 3 plus 4 7, and 7 plus 8 is nothing but 15. Okay, this is 15. Then what is the value of this 1 0 0 1 1 plus 8 is nothing but 9. Okay, and this one is same, right? 1 1 1. So what is the value? Value is nothing but 15 only, right? That's right. So 15 plus 9 plus 15 is nothing but 39, and this is going to be my output, right? So I hope that you guys are clear, right? So now let's write the code for this one. So we are just going to write the same thing that I have explained. Okay, so now first write for, okay, we are going to check row by row, right? So what I am going to do here, I am going to write for int I is equal to 0, I is less than rows I plus plus, and then I am going to check if grid I 0. Okay, so I am checking the my first column, right? I am only going to check first column first, right? This column, row by row, I am going to check for first column. Okay, if any bit value is 0, okay, if any bit value is 0, then in that case I need to flip all the bits, right, in that entire row. So I am just going to write here flip the entire row. Okay, so here for int j is equal to 0, j is less than my calls j plus plus, and after that I have to just flip. Okay, so what is the new value of grid of I, and j's new value is 1 minus 1 minus grid of I j. Okay, so I am flipping the entire bits. Okay, so this is clear. I hope this is clear, right? Okay, row by row I am checking here and then flipping the bits if the value of the most significant bit is 0. Okay, so this, I hope that this line is clear, right? Then after that we have to ensure that each subsequent column has more ones than 0. Okay, so for that, now right now we need to start from my column 1, right? For int j is equal to 1, j is less than calls j plus plus. Okay, this is done. Then after that we have to check for the zeros count, right? So here I am creating one variable 0 count, and I am setting the value as 0 initially, and then after that I have to check in each row, right? For int I is equal to 0, I is less than rows I plus plus, and then after that I am going to check if grid I of j's value, okay, if grid of I of j value is equal to 0, then I have to just increment my 0 count. Okay, I am just taking the count of zeros, right? Okay, so if I already know the count of 0, then definitely I know the count of ones as well. Okay, so let's create one variable int 1 count, and int 1 count is nothing but number of total rows minus my 0 count. Okay, so this is going to give me the number of ones. Okay, this is done. Then after that I have to check if 0 count is greater than my 1 count, right? Then in that case we have to flip the entire column. Okay, flip the entire column, right? So here I am going to write for int I is equal to 0, I is less than rows I plus plus, and inside that I have to just update grid of I j as 1 minus 1 minus grid of I j. Okay, I have to just flip. Okay, so if grid I of j value is 0, then 1 minus 0 is nothing but 1. If grid of I j value is 1, then 1 minus 1 is 0. Okay, so definitely it's changing every time, right? So I hope that this line is clear. Then after that, okay, this is already done, right? Now only few things are pending. Then after that we have to just calculate the final score. That's it. So let's create one variable int score is equal to 0. Then after that run one loop for int I is equal to 0, I is less than rows I plus plus, I plus plus, and then for int j is equal to 0, j is less than calls j plus plus, and inside this int value is equal to grid of I comma j. What is the value of my grid I of j? And I need to multiply this value with let's change the type to int math dot power 2 comma calls minus j minus 1. Okay, this is done. Then after that we have to just increment the score. Okay, score is equal to score plus value, and in the end we have to just return the score. Okay, so how why I am writing this line. Okay, so I will explain, just give me 1 minute. Okay, return score. Here I am just going to return the score, and let's run the code. So there is one compiler error, should be outside this. Okay, this should be end here. Now just format the code and let's run it. So see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So now let's understand how I am writing this line. Okay, so math.power int value. Okay, how this line is coming. Okay, so let me copy this here. Okay, this is the line. Okay, so here this is my final matrix. Okay, so I need to calculate the values of like this 2 0 2 1 2 2 2 3. Okay, so how I am going to calculate the values? Okay, so grid I of j, I am going to take any pick value, like let's say I am picking this value, grid of I of j. Okay, grid of ij into, okay, 1 into, okay, if this value is 1, then 1 into, then after that this is 2 power 3. Okay, 2, then tell me what is the number of my columns. So number of my columns is nothing but 4. So 2 power 4 minus which index I am checking right now. I am checking for this index 3. I am checking for this index. So this index is nothing but 0 na, 0 1 2 3. So index is 0. 4 minus 0 and then minus 1. Okay, this is the formula, right? Math.power 2 calls minus j minus 1. Okay, so this is nothing but 1 into 2 power 4 minus 1 3. So this is nothing but 8. Okay, so this is how I am getting the value. This value is 8. Same way I have to get this value. So this value is 8. This value is nothing but 4. This value is nothing but 2. This value is nothing but 1. So if I am going to add these values, so I am going to get 15, and here I am updating the value as 15. Okay, so I hope that you guys are clear. Okay, so what is my space time complexity and space complexity? So space complexity is going to be of one constant space, because since we are just defining the constant space. Okay, so we are just defining the length of rows and columns. So of one is going to be my space complexity, and my time complexity is going to be of rows into calls. Okay, so see, this is one nested loop, right? So it is running for rows times, and then inside this it is running for calls time. Okay, row into calls. This loop is also running calls into rows. Okay, rows into calls time. Okay, and here also it is running rows into calls time. So overall I am just going to say that the time complexity is going to be of rows into calls. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.